Welcome back to The Explainer. So, when we think of ancient Greece, our minds immediately go straight to the gods, right? Athena, Apollo, Zeus. We picture these grand, pristine temples just standing proudly on the hillsides. But today, we're stripping all of that mythology away. We're looking past the marble facades to reconstruct the everyday human world of the people who actually built these structures. We're going to examine the sweat, the absolute sheer physical constraints, and the ingenious technology of the ordinary citizens, the resident aliens, and the slaves who literally dragged mountains across the earth to build eternity. Let's get into it.
Okay, let's dive right into this because it presents a profound physical mystery. How exactly did a pre-industrial society manage to extract, transport, and perfectly assemble millions of tons of stone? I mean, they didn't have diesel engines, no hydraulic lifts, no computer-aided design. What they did have was human muscle, animal power, and a remarkably deep practical understanding of physics. To truly grasp the monumental scale of their achievement, we basically have to completely rewire how we view these ancient spaces. You see, our modern perception of Greek temples is completely backwards. We visit them today as these silent, pristine, white stone ruins. We think of them as serene places of quiet reflection. But the historical reality? It was a massive, living, industrial complex. An ancient construction site was a deafeningly noisy, dust-choked environment bustling with thousands of laborers. And when they finally finished, they weren't stark white. They were vibrantly painted in bright reds, deep blues, and gold that just absolutely glistened under the Mediterranean sun. But to understand how they got there, we really need to start at the source. So let's transport ourselves to the micro scale of Mount Pentelicus. This is a massive marble quarry about 10 miles northeast of Athens. I want you to just imagine the sensory overload here. The air is thick with marble dust. There's this constant, deafening clink, clink, clink of iron striking stone. You'd hear the shouts of the overseers, the groans of oxen hauling weight, the clanging of blacksmiths who were constantly having to resharpen tools right there on site. The entire process of building a temple began right here, with everyday men basically battling the mountain face to face.
And the crazy part is they did it using the most basic elemental tools. The stonecutters relied heavily on percussion tools, basically tools they struck with heavy metal or wooden mallets. The undisputed workhorse of the quarry was the point chisel. This was used to violently shatter and remove massive quantities of stone. Just imagine the sheer exhaustion, the muscle fatigue required to remove a staggering 85% of the excess stone using just this simple pointed iron tool, entirely by hand. After that, they'd follow up with a tooth chisel to smooth out those rough pockmarks, and then a flat chisel for the really fine details. And for deep channels, 2 workers would operate a cord drill, rapidly pulling a leather strap back and forth to rotate a bit into the stone by sheer abrasion.
But before they could even think about carving a column or a statue, they actually had to get the block out of the mountain. And this required some incredible ingenuity. The Greeks prioritized getting a perfectly clean release from the bedrock. So to pull this off, quarry workers would chop deep trenches into the stone with heavy iron picks. Then they'd insert a series of wooden wedges into those trenches, and they would soak those wooden wedges with water. As the wood absorbed the water, it naturally expanded with such tremendous, unstoppable force that it would cleanly split the solid marble right along its natural faults. It's just brilliant. Using this exact method, they'd extract a single colossal block of raw marble. Now, I want you to keep a number in mind as our memory thread for the rest of this explainer. 40 tons. That was the weight of a single, freshly extracted block of Pentelicus marble intended for, say, a large architectural element. Now imagine the sheer, visceral terror of being an ordinary person armed with nothing but hemp ropes and your own muscle, trying to control a 40-ton block of stone on a steep mountain face. The physical vulnerability involved here is just staggering to think about. Because of the immense difficulty of transporting all that weight, the stone was heavily processed right there in the quarry. Over the course of about 2 whole months, stonemasons would chip away at this raw block, slowly transforming it down into a roughly shaped 12-ton column capital. But in doing so, they generated a massive 22 tons of waste debris from just that one block. All of that rubble had to be cleared out by unskilled laborers or repurposed on site. Only then, once the block was finally stripped of its excess weight, was it actually ready for its agonizing journey. And this brilliantly illustrates the ultimate constraint shaping all these ancient projects, which was geography. For the Parthenon, that 12-ton roughed-out block had to travel 10.5 miles from Mount Pentelicus all the way to the Acropolis. In fact, the cost of quarrying and transporting stone was the single largest expenditure in temple building. Moving marble over land was just incredibly laborious, and it was exponentially more expensive than moving it by sea.
To make this grueling journey across the plains of Attica, the Greeks relied on a heavy, rigid wagon, known as a tetrakycle, drawn by dozens of oxen. To put this ancient technology into perspective for a second, a modern articulated lorry carries roughly 30 tons of cargo. This ancient tetrakycle, made entirely of wood, could support up to 20 tons. But it was an incredibly inflexible beast of a vehicle. It required heavily maintained, specially paved roads just to prevent it from sinking into the earth under the crushing weight of the marble. Just imagine the absolute logistical nightmare for these workers if a wooden axle snapped midway through the journey.
Then came the final hurdle, and honestly, it was the most dangerous one, ascending the steep slopes of the Acropolis. To achieve this, engineers used what's called the balanced wagon method. They attached the loaded wagon to a heavy hemp rope, looped that rope around a massive wooden or stone pole at the very top of the hill, and then attached the other end to an empty wagon rolling down the hill. This created a lateral pulley system, but to prevent a disastrous runaway rock slide if that rope snapped, which would have been a truly catastrophic event, workers had to constantly walk right alongside it, double-chalking the wheels with blocks the entire way up. It was a painstaking, incredibly high-stakes process. Now, what's really interesting about this is we don't have to guess how this massive logistical feat was organized. We actually have the receipts. The Greeks carved their building specifications, financial accounts, and contracts directly into stone steles. These inscriptions reveal a society where monumental architecture wasn't just decreed by some king from on high. It was actually managed through a highly structured, democratic administrative apparatus.
Here's how it worked. The People's Assembly would vote on a project, and then appoint a building commission. These were everyday citizens, chosen by lot, to oversee the whole thing. You had the epistatai, who were the overseers making sure everything met the strict specifications, the tamiai, who managed the immense treasuries, and of course the architect. And because there was no single ancient mega-corporation to build an entire temple, the commission broke the project down into dozens of separate, highly specific contracts. A single temple might actually have over 40 different contractors handling all the different elements of the stone and metalwork. And what about the human layer here, the wages? Well, from the records of the 4th century BCE, we know the standard daily wage for a skilled craftsman was 2 drachmas. But here's the fascinating part. The architect, the master designer of the entire monumental project, received the exact same daily wage of 2 drachmas. This perfectly anchors the massive, almost divine scale of these temples right back down to the pocketbook of the everyday laborer who was just trying to feed their family. What is also truly surprising to our modern sensibilities is the composition of this workforce. You had free citizens working shoulder to shoulder with resident aliens who were known as medics and enslaved people. And the financial records from sites like the Erechtheum show this startling equality on the payroll. Whether you were a free citizen or a slave, if you were doing the exact same skilled job, you were paid the exact same wage. Though, of course, the harsh and somber reality for the enslaved worker was that a significant portion of those hard-earned wages went straight into the pockets of their master.
So, once those diverse crews finally got the stones onto the site, they had to lift them. Now, earlier civilizations, like the Egyptians, built massive dirt ramps to drag stones into place. But around 515 BCE, Greek engineers made an extraordinary technological leap. They invented the mechanical crane. This was a massive paradigm shift in human engineering. Using complex systems of pulleys, winches, rope channels, and specially designed iron lifting tongs, they could hover multi-ton blocks high into the air, fit-check them, lower them back down for fine-tuning, and then set them perfectly into place, all without needing a literal mountain of mud scaffolding.
So the crucial point is, once those stones were lifted, how did they actually secure them together? Surprisingly enough, the ancient Greeks did not use mortar at all. Instead, they carved highly precise dovetailed joints right into the marble. To bond the stones vertically, like stacking the drums of a column, they used bronze dowels. To bond stones horizontally, they used iron H-clamps. They'd place the iron clamp into a carved channel and then pour in molten lead. The lead prevented the iron from rusting and expanding over time, and it actually acted as a shock absorber during earthquakes. The surface joints were carved with such extreme, unbelievable precision that even standing there today, you couldn't slip a razor blade between the blocks. Let's move to see how this builds into the final picture.
When you step back and look at this entire process, you realize that the Greek temple wasn't just a house for a god. It was a remarkable combination of manual skill and mechanical ingenuity. It was really the ultimate culmination of an entire civilization's collective ability. It required the harsh, deafening labor of the quarrymen, the precision of the blacksmith, the democratic organization of the assembly, and the brilliant mechanical engineering of the crane operators. They took raw bedrock and, through sheer human will, transformed it into these structurally flawless, vibrantly painted masterpieces.
Which leaves us with a rather profound final thought. The Parthenon has stood for over 2.5 millennia. It has survived wars, explosions, and the relentless march of time, all because of the painstaking care and ingenuity of those ordinary workers earning 2 drachmas a day. As we look around at our modern glass and steel skylines today, we really have to wonder, in 2,500 years, what modern monuments built by our hands will possess the endurance to survive and tell our civilization's story? Thank you so much for exploring the everyday grit behind ancient glory with us today.